Hello everyone. In this lecture, we'll be seeing linear PDE of homogeneous type 3 problems. As I have said in previous lecture, type 3 problem is nothing but f of x comma y is equal to x power m into y power n. It is x raised to the power of m and y raised to the power n. So if we have these kind of right hand side terms, we already know that the general formula for particular integral is nothing but 1 by f of t comma t dash into our function f of x comma y. Now replacing that. No need to replace any d term and d dash term here. Straight away we have to bring that d and d dash to numerator and we will be writing it in inverse form. Using inverse formula we have to expand this one. Thus, two binomial formulas will be using either 1 plus x the whole inverse or 1 minus x the whole inverse. We already know that 1 plus x the whole inverse is nothing but 1 minus x plus x square minus x cube plus etc. And 1 minus x the whole inverse is 1 plus x square x cube plus etc. So this will be in ascending powers of d comma d dash. Then we have to operate the same on x power m, y power n. So note that whichever power is higher, that is in this x power m, y power n, if x power is higher, then we have to take d term outside. So we can write d dash by d format. And if n is higher, then we are going to take d dash term outside. Then we can write a function in terms of d by d dash. Always note that dou by dou x, we already know that it is d. So 1 by t is nothing but integration with respect to x. Since dou by dou y is represented by d dash, 1 by d dash will be integration with respect to y. Now let us see the first problem. In this first problem, first we have to find the complementary function. To find the complementary function, we have to write the auxiliary equation. Replacing d with m and d dash with 1, we'll get this equation as auxiliary equation. Now we know that we can write it as m plus 1 into m minus 2 is equal to 0 using factorization. So we can get the values of m as minus, that's m plus 2, minus 1, minus 2. So our complementary function will be f1 of y minus x plus f2 of y minus 2x. This is our complementary function. Now to find the particular integral. So I'll do here in this page. Particular integral is nothing but the question given us d square plus 3d d dash plus 2d dash square. We can refer the question once. D square plus 3d d dash plus 2d dash square. So the same thing into x square y square. Since both the values are same, I am going to take d term outside. Even you can take d dash also, but here I am going to take d term outside. So we can write it as 1 by highest power in d term is d square. So I am going to take d square outside. We can write it as 1 plus, if we take d square from the second term, we'll get 3d dash by d, and from third term it will be 2d dash square divided by d square, because there is no d square term in third part, into x square y square. Now we can see this as a x part. So 1 by d square, we are going to keep it as it is, into 1 plus, I am going to write this term as 3d dash by d plus 2d dash square by d square the whole inverse into x square y square. Now this is in the form of 1 plus x the whole inverse. So if we expand that using that formula, we'll get 1 plus x into plus x square term will be there. It is 3d dash by d plus 2 d dash square by d square the whole square plus etc. into x square y square. Now observe that we cannot sum all the values up to infinity. So after some finite terms, we'll get 0 as the answer. We have to fix up to which order we are going to have in this question and from which order we are going to eliminate. Observe that d dash is nothing but derivative with respect to y. So the highest form we are having x square y square. If I differentiate it once with respect to y, x square is a constant. If I differentiate y square, I'll get 2y. And d dash square will be 2x square is a constant. If I differentiate y, I'll get 1. Then d dash cube will be 0. 2x square will be treated as constant. Okay. From d dash cube, I can omit the terms. Up to that term, I have to keep in this question. So it is 1 by d square into 1 plus d dash is here. So I am going to keep it 3 d dash by d plus d dash square is there. D dash square also we are having some values. So it is 2 d dash square by d square. It is in the form of a plus b the whole square. So first one I can square a square term. It will be, so it is 1 plus x the whole inverse. So we will get 1 minus x plus here it is minus. So this term, so mm, so here it is 1 minus, here we'll get 1 minus, this term is also minus. Plus if I square the first part, you'll get 9 d dash square by d square. And then AB term I'll get d dash cube because in A d dash is there, B d dash square is there. If I multiply both the thing, I'll get d dash cube. So d dash cube is 0. From that term I can omit. And B square it is d dash power 4. So up to this term it is enough. X square y square. This is equal to 1 by d square. So d dash square by d square is common to these two things. Minus 2 plus 9. If we do that, 1 minus 3 d dash by d plus 7 d dash square by d square into x square y square. Now we can bring that x square y square term inside 1 by d square. 1 into x square y square will be x square y square minus 3 d dash by d into x square y square. It is plus 7 d dash square by d square into x square y square. If we apply d dash of x square y square is nothing but 2x square y. So it will be minus 3 by d 2x square y. D dash square of x square y square is 2x square. So it will be 7 by d square into 2x square. We can write it as 1 by d square into x square y square minus 6 by d into x square y plus 14 by d square into x square. This can be written as, we can bring that 1 by d square inside, 1 by d square into x square y square minus 6 by d cube into x square y plus 14 by d square d power 4 into x square. So up to this part we have find it. Now it remains to do one more step. 1 by d square of x square y square. So the term given here is x square y square. If I put 1 by d, 1 by d is nothing but integration with respect to x. So if we integrate this one, y square will be treated as constant and x square integral value will be x cube by 3 and 1 by d square is there. Again I have to differentiate it. So y square will be same constant. If I raise x cube, it will be x power 4 by 4. Already one 3 is there in denominator. So it is x power 4 by 12 y square, the first term. And if we come to the next term is nothing but 1 by d cube 6x square y. So 6x square y is there. So if I find 1 by d first term, y will be constant, 6 x cube divided by 3 will be there. So it is 2x cube y. 1 by d square. So here I can do that 2x power 4 by 4 y. So this 2 will get cancelled, and then 1 by d cube we can write x power 5 by 5. Already one 2 is there in denominator, by 10 into y. One minus sign there is there, so it is minus 1 by 10. Now it remains to find the last term. That is, last term is 14x square. For that we have to find 1 by d power 4. First let me integrate once 1 by d. I'll get 14x cube by 3. And then 1 by d square will be 14 into x power 4 divided by 3 into 4. If I cancel this, I'll get 7 by 6. And then 1 by d cube is nothing but 7 into x power 5 divided by 2 into 3 into 5. Then 1 by d power 4 is equal to 7 into x power 6 divided by 2 into 3 into 5 into 6. 6 3s are 18, 2 5s are 10. So our denominator value will be 180. 7 x power 6 divided by 180, the last term. So complete solution will be complementary function plus particular integral. We'll get the answer. Next question. So in this question, this will be our auxiliary equation, and the roots are m is equal to -1 -5. Then CF is f1 of y minus x, f2 of y minus 5x. Now to find particular integral, we have to write 1 by d square plus 6d d dash plus 5d dash square into x y power 4. And note that the power of the term y is larger, so we have to take d dash square term outside. So d dash square term is along with the constant 5. So we are going to take the entire 5 d dash square outside. So it will be d square by, there is no d dash square term in first. So divided by 5 d dash square plus 6d divided by 5d plus 1 xy power 4. Now we can rearrange this term as 1 plus x the whole inverse. This one we have to treat it as x, and then we, using the formula, we can write it as 1 minus x plus x square minus etc. into xy power 4. Now we have to determine up to which power we are going to keep in this question. So the term is x y power 4. If we differentiate this one, see the numerator it is all of differentiation with respect to x. So d of x y power 4 will be, y power 4 is treated as constant. If we differentiate x, we will get 1. So it is y power 4. Then d square, again differentiating this one, we'll get 0. So from the second power term we can eliminate. Up to 1 powers we can keep it. So 1 we are going to keep, 60 by 5 d dash we are going to keep. We have to leave this part, and this part will also be left out, since while squaring it we'll get more than 2 powers. So 1 minus, or 6d by 5d dash will be having 1 minus 6d by 5d dash into this part. Now we are going to bring this one inside the bracket. So this one with this and this one with this. So d, once d of x y power 4 is nothing but y power 4. So here we are having d of x y power 4 as y power 4. Now we can bring this term inside, 1 by 5 d dash square x y power 4. 6 by 5 into 5 will become 25 d dash cube y power 4. Now take the term xy power 4. First one we have to put 1 by d dash. 1 by d dash we have to keep back x as it is. Y power 5 by 5 will be there. And 1 by d dash square, x will be as it is, y power 6 divided by 5 into 6. So it will be x y power 6 divided by 5 6 are 30. And already one 5 term is there. So 30 into 5 will get 150. Next one, y power 4 is there. We have to integrate it thrice with respect to y. So 1 by d dash will be y power 5 by 5. Then 1 by d dash square will be y power 6 by 5 into 6. Then 1 by d dash cube will be y power 7 divided by 5 into 6 into 7. Now 5 6 are 30 and 30 into 7 denominator we are having 210 as the answer. And then one more term, we are going to multiply this with 6 by 25. So 6 by 25 into y power 7 divided by 210. So if I cancel this, I'll get 270. 1. This is 35. 25 into 35, our answer is 875. So we'll have minus y power 7 divided by 875. The complete solution will be complementary function plus particular integral. Let us see this question. X plus y the whole square. This will be our auxiliary equation. We can write it as m plus 5 into m minus 1 is equal to 0. So the roots will be 1 and minus 5. This is our complementary function. f1 of y plus x plus f2 of y minus 5x. Now, to find the particular integral, we are writing 1 by f of d comma d dash into capital F of x comma y. Here we are having x plus y square. And note that y square has the highest power. So we are going to take d dash term outside. D dash term means entire minus 5 d dash square outside. So the first term becomes minus d square by 5 d dash square. The second term, it will become minus 4d by 5d dash. Third term is plus 1. Then I can write this one as 1 minus this part, the whole inverse. So if I expand this one using the formula, we'll get 1 plus x square plus etc. Now we have to determine up to which power we are going to keep. X plus y square is there. In numerator we are having d, so we have to differentiate with respect to x. So once d of x plus y square will be derivative 1 plus 0 which is equal to 1, and then d square of x plus y square will be 0. So from the second power we can eliminate it. So I'm going to keep 1 and I'm going to keep 4d by 5d dash. That's all other cube terms we are going to eliminate. Only two terms we are going to keep. This is d dash. Okay. Now multiply this term inside our bracket. 1 into x plus y square will be x plus y square. Then 4d into this part. We know that d of x plus y square is equal to 1. So we can replace d into x plus y square as 1. We'll get 4 by 5 d dash. Now minus 1 by 5 d dash square is there. Separately we are going to multiply for all the terms. So minus 1 by 5 d dash square into x minus 1 by 5 d dash square into y square minus 4 by 5 d dash cube minus 4 by 5 d dash cube into 1. So x is there. We are going to integrate with respect to y. So 1 by d dash will be x, y. Then 1 by d dash square will be x, y square by 2. Okay. So for the first term, we are having minus x, y square by 2. In front, we are having 1 by 5. And next term it is y square. 1 by d dash will be y cube by 3. Then 1 by d dash square will be y power 4 by 3 into 4, which is 12, and minus 1 by 5 term is also there. So it is minus 1 by 5 into y power 4 by 12. Then the last term is 1. If I integrate with respect to y once, I'll get y. If I integrate with respect to y twice, I'll get y square by 2. If I integrate with respect to y thrice, I'll get y cube by 6. But already minus 4 by 5 is there. So minus 1 by 5 into 4 into y cube by 6. So this will be 2, this will be 3. So it is 2 by 3, 2 by 3 y cube. So if we take this minus 1 by 5, minus 1 by 5, minus 1 by 5 term outside, we'll get xy square by 2, y power 4 by 12, and 2 y cube by 3. So this is our final answer. Complete solution, which is complementary function plus particular integral. Thank you.